as well. Today we're going to find the reason why the integral of arctangent of x dx is actually equal to x arctangent of x minus 1 over 2 ln x squared plus 1 plus c. Kind of seems a little bit random, this formula, but it's very easy to fall back upon. So hypothetically, if you ever forget this answer in an exam, you can always just reprove it very easily. Like I said, very practical to know this, but I'll show you how you can actually elaborate the formula yourself. So to find the integral of arctangent dx, you actually need to use integration by parts. So if you guys remember in your classes, integration by parts is given by the formula u times v minus the integral of v du, right? Typically u is the element that's easier to derive, and v is the element that's easier to take the integral of. In this integral right here, we have two components. We have arctangent of x, and we have dx. So from your calculus 1 classes, you should know already what the derivative of arctangent is. So if we see that u is our arctangent of x, du is simply 1 over 1 plus x squared dx. And then let's find v. So we have dx, but I said that v needs to be integrated. So we're going to write it as dv. dv is equal to the other components, which is dx. To find v from dv, you need to take the integral of dv. If we integrate one side, we have to integrate the other. There. So we have v is equal to x. So very simply, let's plot this back into our formula. So I is our integral, and our formula stipulates that we have u times z minus v du. So let's put u. So u is this guy over here. So arctangent of x, and then v is right here, times x, minus v again, so it's x, du. So you multiply it by your du argument right here. Perfect. Now, we still have a little bit of a problem. This integral right here can't be solved extremely easily. Well, it could be, but just not very obvious immediately when you first start doing calculus. We know that the u-sub technique is able to knock out the x in the numerator. So let's do that. Let's place u as being equal to 1 plus x squared. If we take the derivative of u, let's also take the derivative of the other side. So that will be giving us 2x dx. We'll write it like this: du over 2x is equal to dx. So if we continue our integral here, we have I is equal to the arctangent of x times x minus the integral of x over u now, because that's what we replace it with, times du over 2x. Typically we'll never put the x's under the argument with a u. I'm just showing you for demonstration purposes. You actually wouldn't even write this step, you would just write 1 over u, right? But I'll just show it for now. We knock these two out, because they simplify, and we take the 2 out because it's a constant. So we'll have this being equal to the arctangent of x times x minus the integral of 1/2 of 1 over u du. We know from our base formulas that an integral of 1 over x dx is equal to ln of the absolute value of x plus c. So in this case, it's very simply the same thing. We get arctangent of x And I'm going to put the x in front right here so we don't get confused. Minus 1 over 2 times ln of the absolute value of u plus c. Now remember, we can't just leave our answer like this. If we had x's in the beginning, we can't leave u's in the end. So let's replace. We have x arctangent of x minus 1 over 2 times ln of, we replaced u with 1 plus x squared. We'll do the same thing, 1 plus x squared plus c. So if you guys noticed in my formula in the beginning, I didn't have the absolute values on my ln. You see I actually have just brackets right here. Now both answers are acceptable. It's just you don't actually really need the absolute values here. Because if you think about it, 1 plus x squared could never give you a value inferior to 0. It's not true. Think about it. Any x value you can put in here will never give you something inferior to 0. So there's no need for the absolute value here anyways. So we'll just write x arctangent of x minus 1 over 2 times the ln 1 plus x squared plus c. So this is the answer to our integral of arctangent of x dx. So a little bit laborious, but I think it kind of now might make sense to you how we find this completely random formula from the arctangent of x dx. It's elaborated by parts, and we also have a u sub in it. So I hope this video is useful to you. I recommend you still try to remember it by heart, but also know that you can also find it this way on an exam if you ever do forget. So best of luck in your classes in calculus, and keep working, keep doing those examples. Have a nice day.